Hi everyone, in this video I'll show you how to solve linear simultaneous equations using the method of elimination. We'll start simple and build up gradually. And in the final example, I will highlight a case that often confuses students and show you a simple trick to deal with it. Let's begin. In my last video, I solved this pair of simultaneous equations using substitution, and it got a bit messy. But notice something nice here: the coefficients of y are equal in size but opposite in sign. That makes this pair a perfect candidate for the elimination method. I will add the two equations, and by doing so, the 5y and the minus 5y will cancel out. And then on the left, I have 2x plus 4x equals 6x. And on the right hand side, I've got 18. So x comes out to be 3. Substituting this 3 into any of the two equations will give me y. Let's substitute in equation 1. So 2 times 3 plus 5y is equal to 16. So 5y is equal to 10. Y comes out to be 2. Final solution, x equals 3. Y is equal to 2. For this next example, substitution wouldn't be too bad, but elimination is still a quicker option. I'm looking at the coefficients of x and y, and nothing cancels out straight away, so I need to create a pair of terms that will eliminate. I noticed that if I multiply the first equation by 6, I will match the coefficient of x in the second equation, so let's do that. This will give me 6x plus 18y is equal to 42. I will keep the second equation the same. And as before, I will add the two equations. The 6x and the minus 6x will cancel out. On the left, I'll get 23y, and on the right, I'll get 46. So y is equal to 2. I will substitute this into the first equation, although the second one will do as well. So x plus 3 times 2 equals 7. X comes out to be 1. So final solution, x equals 1, y is equal to 2. For this example, multiplying an equation will not match the coefficient of x or y in the other equation. So the first step is to choose which variable to eliminate. I'm going to eliminate y because the coefficients 4 and minus 3 are easier to match. To make them cancel, I want both to become 12, but with opposite signs. So I'll multiply the first equation by 3 and the second equation by 4. The first equation will become 9x plus 12y is equal to 30, and the second equation will become 20x minus 12y is equal to 28. Again, I will add the two equations. The 12y and minus 12y will cancel out, so I'll get 29x is equal to 58. So x comes out to be 2. Substitute x equals 2 into the first equation. So 3 times 2 plus 4y is equal to 10. So 4y is equal to 4. Y is equal to 1. Final solution, x equals 2. Y is equal to 1. In this example, the equations are not written in the usual xy format, so the first thing to do is tidy them up. I need the x, y, and the constant to be one underneath the other. So I will write the first equation as 3x plus 5y is equal to 19, and the second one as 6x minus 4y is equal to 10. Now, I will repeat the process of the previous example. I'll multiply the first equation by 4 and the second by 5. Doing so will give me the following two equations. And now let's add them. 20y and minus 20y cancel out. Left hand side will give me 42x, right hand side will give me 126, x comes out to be 3, replace x equals 3 into the first equation, so 5y plus 3 times 3 is equal to 19, y comes out to be 2, final solution, x equals 3, y is equal to 2. For this example, elimination is still a good choice, and the second equation makes things easy because it already has y on its own. To eliminate y, I want the coefficient of y to match. I will multiply the second equation by 4. This will give me 12x plus 4y is equal to minus 20. I'll keep the first equation the same. So now what has changed is that the coefficients of y have the same sign and are equal, while before they had the reverse sign. So instead of adding the two equations, I will have to subtract the two equations. Doing so, the 4y and the 4y will cancel out, and I'll get 5x minus 12x equals minus 7x. And on the right hand side, be careful, 1 minus minus 20 is positive 21, so x is equal to minus 3. Go to the second equation and replace x with minus 3. So 3 times minus 3 plus y is equal to minus 5. So minus 9 plus y is minus 5. Y comes out to be 4. Final solution, x equals minus 3, y is equal to 4. Some students do not like having this minus minus, and they prefer to always add the equations. To do that, they need to create opposite coefficients. So in this case, I'll keep the first equation the same, and I will multiply the second one instead of 4 by minus 4. This will give me minus 12x minus 4y is equal to 20. So now I will add the two equations. The 4y and the minus 4y will cancel out. On the left, I'll get minus 7x. On the right, I'll get 21. Like before, x is minus 3. And then substitute to get the value of y, which comes out exactly like before, which is y is equal to 4.